This is ME416 Project 3 Heat Exchanger Design Cooling System for MSU's High Performance Computing Center. I'm Jason Seeley.
And I'm Cody Little. Background information for this project. In this project, the design team was asked to develop preliminary design specifications for a heat exchange system to be used to cool the computers at the High Performance Computer Center on Michigan State University's campus. This project has been suggested by the Office of Infrastructure Planning and Facilities. A suggested method of reducing associated costs with this project is the utilization of drinking water circulated on MSU's campus to act as the cooling fluid in the heat exchange system. This water flows out of a relatively large reservoir located near the engineering building and would be an ideal source of cooling fluid if the following design parameters can be met.
The design parameters that need to be met are 1 megawatt of thermal energy is generated continuously, 3.27 million gallons per day of water flows out of the reservoir at a uniform rate, water must be between 57 degrees Fahrenheit and 60 degrees Fahrenheit upon exiting the heat exchanger, hot fluid enters the heat exchanger between 90 degrees Fahrenheit and 100 degrees Fahrenheit, operating pressure is atmospheric, current piping has a 14-inch inside diameter, and the heat exchanger cannot exceed 20 feet in length.
We determined that the hot stream fluid will be propylene glycol due to its thermal properties and low toxicity. After entering the data provided by a high-performance computing center, we calculated the flow rate of propylene glycol to be 591,000 pounds per hour. After entering the process data, we decided on the following geometry of the shell and tube heat exchanger.
We decided on a carbon steel split flow shell with bonnets on the front and rear. We then found that the tubes with an outside diameter of 4 cm, thickness of 1 mm, pitch of 6 cm, and arranged in a 30 triangular pattern gave us the best results.
Here are detailed drawings of the shell and tube heat exchanger. The length of the shell was found to be just under 20 feet long and 6 feet wide, and the tube bundle contains 800 tubes.
This figure shows the optimized shell and tube heat exchanger. There is a minimal pressure drop of 0.35 psi for the shell and 1.14 for the tubes. Finally, it was determined that the cost was about $131,000.
The Office of Infrastructure Planning and Facilities, in coordination with Curb Pump and Supply Incorporated or Corrosion Fluid Products Corporation, can construct the shell and tube heat exchanger outline for an estimated cost of $131,000.